Java is one of the most fundamental programming languages that anybody can learn. Despite being so simple, it is a marvel what can be achieved with the use of Java. Hi everyone, I welcome you all to this Java full course session by Edureka. But before we begin, let's look at our agenda for today. So we're going to start out by talking about Java, what it is and why do we need it. Then we're going to discuss a few basic concepts like variables and data types in Java, followed by which we are going to talk about operators, control statements and methods. We are also going to discuss the meat and potatoes of this session, classes, objects and object-oriented programming concepts in Java, followed by which we are going to talk about exception handling. Then we are going to discuss Java collection frameworks and finally close this session by discussing the DOM parser in Java. Also, do click on the subscribe button to never miss an update on the hottest technologies by the Edureka YouTube channel.
Okay, before we start off, let me introduce myself. I'm Vinod and I have been with this industry, IT industry, specifically into Java development for last 12 years. All right, so the first topic is about introduction to Java. So what are we going to cover in this particular topic? So it's going to be introduction to Java, what Java is all about. We'll have Java installation done as well so that you guys can use it in future. You guys can try your hands on. We'll talk about modifiers and variables in Java. This is pretty much similar to what we have in other programming languages. We'll talk about Java data types as well, which is nothing but data type as we have. It's a storage for different data types, right? Or the data that is stored, whatever you want to process on, is first put into memory, and that is what data type is all about. So you have different storages, like for character, you have something else, and for float, you will have something else. For long, you will have something else, sort of. Data type conversion in Java. So you could convert from one data type to other data type in Java. There are implicit conversions done wherein the programmer need not take care about it. Java programming by itself would take care about converting it, which is implicit conversion. And there are few conversions which programmers have to take care about. They have to explicitly mention that you have to convert from this data type to this data type. And if you don't do it, you would end up in compilation errors or something. We'll talk about operators. Operators are nothing but the operators that work upon this data type, and which is nothing but transformation. So you kind of use this operators to add up. For say, for example, you have two integers, you want to add it up, so you would have these operators used. We'll talk about control statements in Java as well. Control statements like you have if else and for loops and stuff like that. So we'll talk about it. So Java is pretty much similar to other programming languages. Thing is, it has some unique features which makes it really important in the current industry, the IT industry, when it comes to big data and stuff like that. So we'll touch base on all these important features of Java, which would help you to understand why do we really use it. All right, so the first topic is introduction. So what is Java? So Java, as we said, it's a programming language which has object-oriented programming model. So when I say object-oriented programming model, everything in Java is taken as an object. So object is nothing but something that has got state and behavior. Say for example, you have chair, right? So chair has got a particular state and it has got a particular behavior. If you do something, if you move it, it would go this way and that way and stuff like that. So basically, any object, if you think about in reality realm, any object for that matter would have some kind of state and it would have some kind of behavior which incorporates on its own, right? So basically, similar to that, Java is programming language which is based on object-oriented programming model. So everything Java could be thought of as an object, or you define a class. So say for example, you have house, right? So house could be thought of as an object or class rather. A house is a class and it would have certain attributes, right? Like number of rooms or stuff like that. So that is nothing but the state of the house. So this was actually brought in by Sun Microsystems in 1995. And basically Java is nothing but we have JVM, but JVM is nothing but you kind of can say it's a specification. right? Sun Microsystems has said that this is how it should be, so that any company tomorrow I can go and create my own version of Java, but it has to be aligned to this particular specification that is given by Sun Microsystems. So Java is nothing but the reference implementation of Java is provided by Sun Microsystems, but nevertheless, as I said, JVM itself is a specification which anyone can implement actually. But we will talk about Sun Microsystems, talk about the reference implementation that is nothing but one created by Sun Microsystems. So everything in Java would have a state and behavior, and which would be defined by class. Again, it was started off by a team led by James Koshling, and we know it's an open source, which doesn't stop anyone from putting in whatever code they want to. Still, we have a lot of versions coming in Java. So it's not that you just have one version created by Sun Microsystems and it's been used across the industry. You have, like, if you find some issues or if they want to have some kind of enhancement in a particular module, they keep doing it. So right now we have, like, Java is at version 12, which is like we have a lot of enhancements coming in. It's a evolving thing. It's ever evolving thing. And as I said, this is open source. Tomorrow, if you become a good programmer in Java, you could go and actually write something for Java, and which would be moderated by someone and which would be put as open source and anyone can use it. Other thing is Java, the very important feature why we use Java or why Java is so widely used is write once and run everywhere. So you write a class or you write program once and you compile it, and this particular compiled version of class could be run anywhere on any machine, or you could transport this particular compiled version of Java, which is nothing but class file. We call it as a class file. Again, you did not get into what is class file, but just to say that you compile it, you get a compiled version of it, and this compiled version of class could be transported anywhere in the network, or you could put it anywhere and just run it. So you could take it on your pen drive as well and go anywhere and plug your pen drive, get this class path, download this class path, or download this class rather, and just run it. So it write once and run everywhere. And the magic part is it could be run on any environment. It could be run on any platform. That's why it's platform independent. So I could write a program today on Windows, compile it, and tomorrow I can just take it on my pen drive and run it on Linux as well. So you don't have to take care about it. Java by itself has a feature to make it platform independent. So, as you could imagine, this is one of the reasons why it's been widely used, because since we are getting into a phase of distributed computing, we cannot have everything run on the same platform. You don't know where so you as a programmer write something, but you don't know where this particular program is going to run. It could be on any platform. So, this is why it is more important. So, unlike .NET, right, you need to have Microsoft. Just to give you this thing comparison with .NET, so for .NET, you need to have Microsoft Stack implemented, but for this, you need not. It could be run everywhere. So Java can be used to create complete applications that may run on a single computer or can be distributed among servers and clients in the network. As I said, this is more about the application of platform independent programming language. So it could be used on any machine. You need not take care about which machine your program is going to run on. All right, so let's talk about Java features. So what features do we have in Java? First thing is Java is pretty much simple when it comes to SDK or when it comes to API, application interface. It's pretty much simple. It's kept as simple as possible. It's pretty much similar to other programming languages, and it's verbose, so anyone can just read through it and understand what it is trying to do. So they have kept it to that level. So similar to any high level languages, right? The code should be such that as you read through it, you should understand what it is doing. And that's what they have tried to do. It's high performance. One of the things that I already mentioned about, it's a evolving system. It's not that it's been just done once and been used throughout. It's a evolving system. So as and when there's continuous improvement done, right? So as and when, if I as an application programmer, if I find something not working as expected, I can raise a ticket and they could go through the ticket, or there's a Java development team which has been driven by Oracle now. they would look at the priority of this particular stuff, and if there are a lot of tickets being raised by other companies as well, and if something could be done on the particular aspect that you raised, they would surely incorporate it and notify you in a particular release the enhancement is coming up and stuff like that. So it's a evolving system, and the performance is always, if there's some drawback or if there's something not working as expected, they would surely rectify it in the future releases. So that way they keep it up to the mark. They keep the high performance thing going. It is secured. So Java basically runs in virtual machine sandbox, and no one can get into this particular space. So no one can intrude it, I would say. So that keeps it free from virus and stuff like that, or untrusted process. And other thing that is important is, unlike C, Java doesn't expose pointers. So in C, there could be malicious user who could get into the memory location through pointers and can manipulate the contents of a particular memory, right? Whereas in Java, it doesn't expose the pointer. It doesn't give you the pointer to a memory location. So you can't actually go and change the content of a memory location when you're using Java. So that keeps it secured. So it's robust. So Java checks the code during compilation time and runtime. So basically what happens is, as I said, when you compile it, you get a class file. And whenever you try to run this class file on any of the machines, it will ensure that it's properly done. Or if there's some issue with the class file, it would say that it's a corrupted class file. So basically, you have some kind of checks done during the compilation as well. Compilation is nothing but if you have some syntactical error, say for example, if you miss a semicolon at the end of a particular statement or an end of any statement, it would prompt you during the compilation time that this is not what is expected, or it would ask you to correct it. Once you have everything as per the expectation, it would compile it and create a class file. And when you port this class file to any of the machines, during the runtime, it checks as well. And the other thing is about, you don't have to take care about memory allocation and releasing, unlike in other programming languages. Java by itself does garbage collection. Garbage collection is nothing but when a particular memory is not being utilized by your program or goes out of scope, it would, Java by itself has a thread. I don't want to get into threads and stuff like that, but Java would clean off the memory contents by itself. You don't have to explicitly write a code to clean it. In C, you have to write a code to clean it, whereas in Java, it's done by itself. So that makes it robust. Other thing is it's portable, as we already spoke. You can write a program in Windows and you can run the same program, or you can write a program in Windows, compile it, get a class file or the compiled version of the class, and just port it on any platform. It could be Windows, it could be you run it on Unix or Linux or Mac or anywhere. So you don't have to take care about it. So Java by itself does it, and that's where JVM comes into picture, which we'll talk about in the further slides. So other thing is it's dynamic, which means that it has runtime polymorphism. So all the objects are evaluated during runtime. It's not just that it's done during the compile time. There's something done during the runtime as well. So basically it's called as runtime polymorphism. But just to keep in mind, not everything is linked up during the compile time. There's something done during the runtime as well. So it could be distributed as well. You don't have to have all the code put into one machine and run it. From my machine, I could run something written on your machine as well, if in the same network, or if they're exposed to a network. We could run programs on different machines. So that's what distributed is all about. So you could think of big data. So this is one of the major features why Java is being widely used in big data, right? So big data is nothing but you have chunks of data. You have like petabytes of information coming in every minute or every hour or every day, right? And you want to process it. So it cannot be done in one machine. If you want to run everything on one machine, as we had earlier, right? Everything was monolithic. Everything was done on one machine, sort of. So that's where you would want to have servers, right? Now this server thing is not being used that much since there's a lot of investment and stuff like that. So distributed computing is nothing but we have like peer computers or normal computers that we have, and programs are actually run on these machines rather than having high-end machines. So basically, this feature is what helps Java to be used in big data. And as I said, it's run on commodity hardware as against server hardware, which needs a lot of investment for companies. Java is multi-threaded. So multi-threaded is nothing but, so you have multiple cores on your machine, right? You have like 4 cores and stuff like that. So you could utilize all these 4 cores. Say for example, you want to do addition of 2 numbers and multiplication of 2 numbers, right? Different numbers. So you don't have to run everything on one core. So this could, since you have 4 processors, right? 4 cores, you could have addition run on one core and you could have this multiplication going on at the same time, at the same instance, right? You could have this multiplication going on as well. You could run them as a thread, right? You don't have to have one waiting for other. You don't have to do it in a sequential manner when you're operating on different variables, right? So that's what multi-threaded is all about. As I said, you could have this operations carried out on different cores at the same instance of time. Object oriented, again, as I spoke earlier, everything is performed using objects, and Java can be easily extended since it is based on object model. Now let's talk about which sectors or which industry sectors actually use Java. So you have Android apps. So Android apps could be written on Java. So basically the underneath is Android API, which is similar to JDK. So JDK is nothing but Java Development Kit. It's widely used in financial services industry. If you would have some idea about it, you could see that mostly all financial companies use Java. So all the legacy systems that we have in financial companies is mostly developed on Java. So one of the aspect for this is more about it's pretty secured. So that's why it's been written on Java. Lots of global investment banks like Citigroup, Barclays, Standard Chartered, and other banks use Java for writing front and back office electronic trading system. So one of the main features why it's been used in financial industry is about security. It provides high level of security, as we spoke earlier. Java web applications. So basically, you have web servers on which your application would be hosted, and you could request for a particular JSP, or JSP is nothing but a dynamic HTML page, right? Wherein the contents could change. Basically, you could request for some particular JSP and you could get it. So, say for example, you are trying to log on to a particular application, you get a login page that is nothing but a JSP. So basically, many of the web applications is developed on Java as well. One of the main features why web applications are developed because you have a lot of web servers supporting Java. You just have to deploy your application on a particular web server and could access it from anywhere across globe. You should be on internet though. Embedded system. When it comes to embedded system, it has to be lightweight, right? So Java 8, I remember Java version 8 had a lot of feature making it pretty much lightweight when it comes to embedded systems. So basically you have micro edition J2ME. What we are talking here is J2SE. And the thing that so there are 3 flavors of Java. So one is J2SE, which is nothing but standard edition, and which is standard edition, which you have like all the data types and stuff like that, all for loops and stuff like that, right? That is about J2SE. You have J2EE, which is enterprise edition, which is nothing but the web application that we spoke about. And we have J2ME, which is micro edition, which is nothing but for embedded systems. As its name suggests, it is micro edition, which is light in weight. And as we can imagine that in embedded system, it has to be lighter since it is burnt into a chip, right? And you cannot have a big application. So that's why we have lightweight when it comes to J2ME. So again, as I touch base on this, it's about web servers and application servers, which makes Java compatible for web applications. So we have Apache Tomcat, which is pretty much widely used. which was a web server earlier. Now they have Apache Tom E, or which is Tom double E, which is nothing but an application server version of it. So basically, when it comes to web servers or application servers, what you do is you as a client could send a request to a web server, and web server or the application server would just process this particular request and send the response the way the application is written. So basically, it would serve the expected result out. So you have enterprise applications. Again, this is Java Enterprise Edition, which makes it favorable for web applications. So all these are specifications, J2ME, J2EE, J2SE. These are nothing but specifications exposed by Java. So if you as a developer wants to do something, or if you want to write your own version of it, you could do it. So where is Java used? Again, scientific applications. So as you could imagine, in scientific applications, you need to have high level of accuracy and precision rather. There could be mathematical equations and mathematical computations, which needs a lot of CPU time because it's very CPU intensive, right? When you do a very precise calculation with high degree, it needs a lot of CPU time, right? So that's where Java is good at. So basically, this is about, as I spoke about multi-threading, utilizing all the cores to the fullest. So suppose you have 4-core processor, using all these 4 cores is being done by Java. Java has feature or through threads, you could actually read through or actually utilize these 4 cores to the fullest. Big data technologies, again, big data is nothing but, as I said, it's distributed. You cannot have everything run on one machine, which was the case earlier. You would have one server put up and everything is run on that particular server. Now it cannot be the case. That's where big data comes into picture, wherein you have distributed architecture and you have this data being processed across network rather than just on one machine. And mind you, as I said, these machines are commodity hardware and not server level hardware or the enterprise level hardware, which makes it cheaper. Internet of Things. So, Internet of Things is coming up, it's a booming thing wherein you could connect things together. Say, for example, you have cars, right? So, you could connect cars together. So, you could have sensors in your car which could emit data and you could connect them together. So, basically, it's all connecting things together. Or say, for example, let me talk about internet itself. So earlier, if you remember, computers were not connected. It were all peer, right? It could just be used for your own purpose. Now internet has started wherein you have all these computers connected, and if you are connected to the internet, you could go on to Google and search something or whatever you want to sort of. So basically, this is what Internet of Things is all about. So consider this, instead of computer, it could be any other object, say car, for example, as I said. So consider car has sensor and it is emitting this sensor data every minute, and we could utilize this sensor data and do something with it. Or one car can know where the other car is. So that's what Internet of Things is about, all about, connecting things together. Let's start off with the setup for Java. So basically, you could go to this particular site and just download the SDK based on this JDK, right? So basically, based on whatever platform you are at, if you are using Windows, you have to select Windows. If you are using something else, if you have Mac, you can select Mac. So this is pretty much similar to other softwares. You get a exe file downloaded and you just have to run that exe file. So basically, if I can show you what gets downloaded. So I've downloaded version 12 for Java, as you could see here, and since it's Windows, it is mentioned as Windows. So this is nothing but a exe file that you get, which you could run, and you would have Java installed on your machine. So it's pretty simple. It's pretty much similar to other softwares you have. Say for example, or I could just show you the location where it is installed. So if you get into the program files, you can see Java being installed here, right? And it says JDK 12. So once you install Java, once you download this particular stuff, JDK, and once you install this executable, you should be able to see this Java folder in your program files. So it shows here. So you can select whatever you want to see. You have, as you could see here, there's Linux, there is Windows, Mac OS, and stuff like that. You have to select the platform you are on, and you should be good to go. This is done. You could see you get a exe which you have to run. So basically, to run Java, what you have to do is, yeah, so you go to the system, you have control panel system, you go here and you have to click on advanced system settings. Basically, what we are trying to do is we are going to set environment variable, right? And what we are going to set is this path variable. So you have, if you want to put it specific to a particular user, you can put it here, put it in the upper space, or if you want it across the system, you could basically put the path variable here in the system variables. So once you install it, you have to make sure that you have this particular path being put in your path environment variable. So basically it tells the OS that you have executables within this particular directory. So once that is done, once you have this properly set up, let me open up PowerShell. So PowerShell is nothing but it's pretty much similar to command prompt, but it's a Linux flavor of it. So basically you could run Linux commands as well. Okay, so I'll once this is done, give me a second. Okay, so with PowerShell you can do ls, which would give you listing. Unlike in command prompt, you have to give dir. So it's basically good for programming. So once you have this properly set, once you have this path properly set, if you write Java here, if you write Java on your command prompt, you should be able to see this help coming up here. So if it's not properly set up, you won't see this. It would give you unrecognized command. Yeah, open command prompt and type Java. So once the path is properly set, you should be able to see this. So let's set up Eclipse as well. So it could be Eclipse or IntelliJ, whatever you are comfortable with. So you could use either of them. Since IntelliJ has much more features, you could use IntelliJ as well. So you go to Eclipse download, and whatever flavor, you can take the latest one, whatever flavor you want to install. If you want a simple one, you can do it. If you're trying to do something on web, you can download that one as well. So basically for simple purpose, for whatever we are going to do, you can have normal ones. So let me quickly open up my, so this is nothing but the IDE integrated development environment that I use, which is IntelliJ. All the IDEs are pretty much similar. So IntelliJ is similar to Eclipse. So it's coming up. So basically what you do is you have to select a workspace first. Workspace is nothing but all your program, all the class files, all the class and everything that you write would be put into this particular workspace. And you can create a new class and start off. So when we get to the Hello World program, which is the first program that we are going to talk about, it would give you a clear idea on what we are talking about. So let's talk about Java internals, how it looks like, and all the features that we spoke about. So basically, so far what we have covered is more about Java is an object-oriented program, or it uses object-oriented programming paradigm, which is nothing but everything is thought of as a class with a particular state and behavior, right? It's platform independent. That's why it's been widely used. It's secured as well. That's why it's been used in banking applications and stuff. It's good for distributed computing since it's platform independent. You just have to write it once and you can run it everywhere. So basically, this platform independent aspect is what helps it to be widely used in big data applications. So let's talk about the internals. So what is JVM? JVM is nothing but, again, it's a specification, right? You could have your own JVM. Sun by itself gives specification for a JVM. This is what the JVM should be all about. So I could create my own JVM, but we usually use the reference implementation of Sun Microsystems or Oracle now, right? So JVM is a virtual machine that runs the bytecode. So basically, there has to be some level of compilation done before JVM can understand it. So that's where you have Java compiler. And so what this does is nothing but it takes your source code, it takes the class files as, or it takes the class that you write as is. So Java compiler would consume it and kind of compile it into a dot class file. So dot class file is nothing but compressed version of it and compiled version of it as well. And this dot class file is nothing but it's also known as bytecode, and this is what a JVM could understand. So once you have this class file, it could be sent to the JVM and JVM could understand it and run the applications. So what makes Java platform independent is this Java compiler is platform independent. You don't have to take care about it. You just have to run the compiler. And whenever you want to run this particular byte code on any of the machines, you just have to have JVM for that particular machine, right? So basically, if you want to have on Linux, right? If you want to run it on Windows, you would have JVM installed on Windows, or you would download the JVM for Windows. And if you want to run it on Ubuntu or the Linux or Mac, you would just have to have the JVM downloaded for that particular platform, and it should be able to sense this particular bytecode. So basically, this is what makes it platform independent, right? As I said, once you have this bytecode, once you compile it, this bytecode could be transported or ported into any of the machines, any operating systems, and you should be able to run it. That is what it is all about. It's write once and run anywhere. So as I earlier mentioned, you could just get this class file into your pen drive and take it anywhere, and you could just plug your pen drive and just run through. That's how simple it is. So this is Java runtime environment wherein you have a set of JVM plus you have libraries. Libraries, it is nothing but all the programs put together, all the program source code for Java put together. So rt.jar is one of the libraries which would have most of the classes, or you have util classes, maybe string class. String is a class itself, which is exposed by Java. So this particular jar file, or it's a Java archive. Jar is nothing but Java archive, which is set of Java classes, or the class files rather, which would have a lot of class files within. So in rt.jar, you would have something like string class and stuff like that. A lot of other classes which is being used by the system, or which is being used by Java itself. So basically in JRE, this is what you have: JVM plus set of libraries plus other additional files. So as I spoke, JVM is nothing but specific to environment, but all these things like rt.jar and stuff like that would be independent. JRE does not contain tools and utilities such as compilers or debuggers for developing applets and application. So JRE by itself is a runtime environment, so it doesn't have compilers and stuff like that. So JDK is nothing but it's specifically for development. You could see here it's JRE plus development tools. You have compilers and stuff like that as well. So to run a class file, you just need the JRE, but if you're a developer, you would need JDK. So what we downloaded earlier, if you remember, that was JDK, right? JDK for Windows or JDK for Linux. So basically, if you see this one, could see here as JDK. So essentially you need JDK only if you're a programmer. If you just want to run the class file, JRE would suffice. So what is JDK, JRE, and JVM? As we spoke about, you could see JDK is a superset. It has everything, right? JDK would have your JVM plus it would have, as we spoke here, it's JRE plus your development tools as well. As you could see here, details, it has everything here. It would be really confusing right now if you directly get into what all this is all about. But basically, you could imagine JDK is a superset and JRE is nothing but it's your runtime environment, which has JVM and some additional files, or rt.jar, as we said, which is nothing but set of files, set of class files that is exposed by Java, which could be used, like string, for example, right? Let's see how it works. So basically you have your source file. So this is what a developer would typically write, would create a .java file. So whatever you write, you create a class, you just create a new class and write something to it. What you get is .java. You get the extension .java. So basically this is your source code, whatever you write, you as a developer would write. This class files would be sent for compilation, or whenever you are good enough done with your coding, you would compile it. And once the compilation is done, once everything looks good enough, once the compiler doesn't mark anything and doesn't flag anything rather, which means everything is syntactically right, you would get Java bytecode, which is nothing but .class file. Now this .class file could be moved across network, or you could, as I said, you could just put it in your pen drive and can take it anywhere. And you could run it on any of the environments. You just have to have JVM. So basically you could run this class file, which is compiled on Windows. You could run it on any of the environment, any of the platforms. So this is something that we spoke about during runtime. There's a verification as well. So when class loader would load this particular class file, it would ensure that it is up to the mark or it's not manipulated sort of. So if at all it sees something wrong, then it would flag it off as, corrupted file or something. So this is nothing but Java class file libraries, rt.jar that we spoke about, Java archive. So this is what is happening when you run a particular class file, right? So you have this class loaded, and then you have this compilers, just-in-time compiler actually running it for you. So basically it's a part of JVM. So JVM is, remember, JVM is nothing but it's a platform. It is specific to platform. So basically for Windows, you would have a different JVM, and for Linux, you would have a different JVM. So yeah, you get this class, you load this class using class loader, and you run through the application or run through the class files. So typically this is how Java operates. So just to give a gist on this one, so you have a source code, you have .java file written, you compile it, you get a .class file, and you can port this class file anywhere. You can run this class file anywhere on your network or wherever you want to. You just have to take this class file, and on the machine on which you run, what would happen is you load this class file first using class loader, and with JVM would have just-in-time compiler, which would run a particular class for you, right? So what we are trying to do here is you're running the source code that's written on any environment. You're running it on any other environment. So basically you could write this on Windows. You could write source code on Windows, but you could run it on, say, for example, Linux. So that is what makes it platform independent. So yeah, let's create one class, and as we create it, I'll talk more about it. So you could open up your Eclipse and could create something like new project. So it could be a bit different for you. The look and feel might not be exactly the same as mine, but you just have to create a new project, select Java. So basically I put a project name, so whatever you want to. So basic nomenclature is like it has to start with uppercase letter, which is camel casing, right? So you should follow camel casing when you, that's one of the best practices. It won't flag you as some error or something, but that's a normal industrial practice that whenever you create a Java project, it has to use camel casing. Create Edureka Java. So it's creating a project for me. And as you can see here, I have this particular project being created, right? Now what I do is I create Java class. So basically, as we said, everything could be seen as a class, right? That's what object oriented is all about. So basically what I would do is I would create a class here. So this is my source folder wherein all my source class would be there. So as you can see here, new Java class. So say I create com.edureka. So this is nothing but your namespace of the package. right? So you could give whatever you want to. Basically, this is to avoid collisions, right? If we don't have a namespace, there would be a lot of collisions within the class. So there are a lot of people working on the same project, right? So I could create a class with name class A, and the other person might create class A as well. So when this is clubbed together into one particular application, there would be collision. So to avoid this, basically what you have is you have a namespace. So I would write as com.edureka.class A, and the other person would write something else, and that would avoid class name collisions or class collisions. So this is com.edureka is my package or namespace, and hello world is my Java class name. So as you could see here, there's a package com.edureka, which is again a namespace. And there's a class by name hello world that's been created, right? And if you want to see, you could actually go and so you can see a folder structure created here in the source. So this is your source folder, right? Within your project, there was a source folder wherein we created the class. So if you go to the source folder, you could see a package structure or you could see a directory structure being created, which starts with com, and within com you would have edureka, and here you can see hello world.java. So remember we said that your source code would have all the Java files. So basically this is what I was referring to. This is a method that's a default method that's been called. So when you run this particular class file, JVM would actually look out for this particular method. So you need to have the same signature as is. So you would have a main method wherein your program execution would start, right? So as in when you compile it and run the class file, so basically when you compile it, you would get a class file, right? And when you run this class file, JVM would check out for this main or a method that has the same signature as this one. That's a main method. And your program execution would start running from here. So basically it's an entry point for your execution, right? So this would be a simple program wherein we would just print hello world. So basically you have like system is a class, and this is how you print in Java. So I don't want to confuse right away by saying what is system, what is out, and println. But basically what you have is system is a class. As I said, everything could be imagined as a class. So in Java, everything is a class. So basically you could just click here and you could see the source code of it, right? This is the source code, and this is coming from rt.jar. Remember in JVM we spoke about in JRE we had rt.jar, we had JRE, we had JVM plus class files. So all this has been written by Java, by the Java community. So basically you can see here this system itself is a class. So out is an instance variable, and println is nothing but a method within out. So what this statement, particular thing is doing is nothing but writing it onto your console. So let's print hello world. So basically when you build a project, it's compiling it. As you could see here, it's saying it's building it. So once it has built it, you could see a class file here, right? So you could see here hello world.class. This is because we built it. When you build it, your Java file would be compiled by your compiler, and it would create a .class file. And remember, as I said, this class file could be run on any machine. So this is Windows machine that have written this file, Java file, and compiled on. Now this .class file could run on Linux or any platform that you want to run it on. So let me talk about this class, right? So you have a public keyword, which is nothing but access modifier, which gives visibility. So basically what we are trying to say here is hello world is could be publicly seen. So it could be seen anywhere within the application. So basically for class level, you have public, which as the name suggests or as the name gives out, it could be seen anywhere within your application. That's a visibility key access modifier. All right, so you have the keyword class here, which is for the class. you need to have it mentioned as class. If you write something else, then it would give you compilation error. So it has to be exactly the same. All right, that's the syntax of it. Hello is nothing but the name of your class. Then you have this public static void main, which is nothing but, as I said, this is the entry point for your application or your class file. So when you run this particular class, it would start off from here. You have a static keyword. Static keyword is nothing but it's at the class level. So basically you need not create instance. We haven't reached to that point yet. So basically hello is a class and you could create instance of hello, which is nothing but object, right? So when you have a static keyword here, you need not create object of hello to run it. If it's not static, then you need to have object of hello created. So basically what I'm trying to say is, say you have one more method here, which is test. Now this doesn't have a static keyword here. So basically what we can do is we can print. So yeah, this is a non-static method, right? Now we cannot call it directly. If it's a non-static, you need to have an instance of hello world created. So basically how you create instance is nothing but hello world. That's your hello world object. So when I say instance, I'm talking about creating object, right? And you could create new hello world. So object of hello world is created using new keyword, right? When you do this, you would get an object of it. Or now what I do is, so basically what I was trying to say is you cannot call test as is. If you do it, you would get a compilation error saying that non-static method test cannot be referenced from a static context, right? You cannot call it without having your object. So basically I can call it on hello world object dot test. Now I can call it. Now it doesn't give me compilation error. I'll create one more static method which would give you some idea. So I'll rename this as non-static test, and this would be static test, right? And we are printing a static method, and here we are printing non-static method. So hello world dot non-static test. Now, whereas the static test did not be called using object, so we could directly call static test. Sorry, I haven't written static here. So this is a static method. Okay. So now you could see here it compiles fine, right? So what I was trying to say is when you have a static method, you did not have an object to call it, whereas non-static method, you need to have object. That's what the static is all about. Then you have void is nothing but the return type. It's not returning anything from here, so that's why it's void. You have main method, that's the keyword, that's the entry point for your application. You have this arguments. You can see string array of strings, which are arguments provided to a particular program. So you could pass on as many arguments as you want. Or if your program is, say for example, you want to pass your name as an argument, you can do that. So this is arguments. Then we have main, which represents startup of the program, which I already mentioned. Then we have system.out.println is nothing but the print statement. So as I mentioned, system is nothing, everything could be thought of as a class. System is a class, out is an instance variable, and println is a method within out. So basically you don't have to think much about it. Just to understand the structure of it, just to understand how a particular class is being written, this is what we have. This is how we write a class, right? Again, just to brief on this, you have access modifier, which denotes the visibility of a particular class. You have the class name, you have the main method, which is nothing but the entry point for your class. You have a static method, which says whether you need an object to call a particular method or could be called directly from a class. You have a return type here. So this is how typically any method would be written, and you can write whatever statements you want to within this particular method. In this case, we have printed out hello world. So basically you could follow this when you do it on Eclipse. So it might be a bit different based on the Eclipse version that you would have, but it should be pretty much similar. All right, so you create a new Java project. So I showed this already on IntelliJ, which is also widely used IDE, but yeah, you could use Eclipse as well. So basically you could see the project name being written as Hello World, right? And here it mentions the JRE to be used. So here you can see class being created. And let's see how we can run this. So we compiled it and we saw that .class file was created. Now we can run this. So as I said, main is the entry point. So it would start running from here. So your program control would come here. And the first thing that it would see is you have printed hello world. So it should print this one. Then I would keep it simple. I don't want to, let's see what's been printed here, right? So you could see here hello world being printed first, right? This is where the program execution started from. So it came to main, saw hello world, it printed out hello world. Then you gave a call to this non-static method. So it printed non-static method, which has been printed in this particular method. And then it gave a call to static method, and you could see static method being printed here. So one thing to remember is the program execution starts from main and it just executes this main method. So whatever content you want to write, you would basically write it in the main method. So you could see here hello world being printed out. Now let's see how easy it is to code the same in the J shell. So J shell is nothing but shell prompt that was created in Java version 9. Since 9 you would have J shell. So since I have Java version 12, I should have J shell as well. So yeah, J shell is nothing but a prompt. So it's nothing but instead of writing into integrated workspace, you could have J shell and you could try out something here. It's not something for production use as such. It's basically to test something, right? You as a developer could, if you want to see what it does, instead of writing everything into the main. So if you write a class, you would have to write things into the main and then run it and stuff like that. With J shell, it's just a kind of interpreter wherein you could write something, some command and see what the output is. So basically you could say, for example, we printed hello world, right? So system.out.println hello world, right? If you remember, this is what we typed into our main method, right? So if you want to run this, you have to have all these artifacts created as is, right? To have a class, you need to have main method and then build the class and then run it. Basically in JShell, you could run it just to see what's output, right? As I said, this is not an application as such. This is just for the developer to test what the output for a particular command would be. And what are modifiers in Java? So one thing that we saw in the program was access modifier. We already saw about actually is this one, right? Public, and we saw public here as well. So these are nothing but modifiers, right? Public, as I said, this public means it's an access modifier which shows that hello world could be accessed anywhere throughout your application. So here we can see it's a word or a phrase, changes meaning of other phrase in some. So basically it's just trying to say that one of the aspects or one thing that access modifier could be used is to control the visibility of a particular class or a method as well. We have an access modifier for your methods as well. So this is just one of the things, right? We would see other modifiers as well. Modifiers in general has some other things as well, but when it comes to access modifiers, it basically controls the visibility of a class, or a method. Or so yeah, modifiers here, as you could see, there's access and non-access modifiers. Let's see access modifiers. So we used public already. So this one is nothing but a access modifier, which is public, which says that it could be used throughout the application. So visible to the world, as it says. public is nothing but visible to the world. If we talk about chronological order, if we talk about the visibility, so default is visible to the package. So default is nothing but within the package it would be visible. So basically you could default is without any keyword, without any access modifier. That's a default scope. So within the package, it would be accessible only within the package. So you have like com.edureka, that's your package, right? So this hello world would be accessible if it has a default scope, it would be accessible only within com.edureka. If you try to access it from some other package, you would get an error. So that's the default visibility, visible to the package. Private is nothing but it is visible to the class. It is only visible to the class. So this is the lowest visibility, only visible to the class. If you try to access it from outside class, even within the same package, you would get an error because you won't be able to access it. It is accessible only within the class. Public is accessible to the world. It could be accessed from anywhere within your application or anywhere within your wherever your class file. So basically, if you have a jar file, but what I'm trying to say is public is accessible anywhere, right? Protected is again visible to the package and all the subclasses. So we'll talk about subclasses. So subclasses is nothing but in C we have inheritance, right? Say for example, integer. Integer is a class. So as I said, in object oriented paradigm or in Java, everything could be visualized as a class. So integer itself is a class, right? So there's a number, there's a superclass, which is number, which has all the common state and behavior that a particular number would have, right? So number is a superclass and you have subclasses like integer. Float would be a subclass of number. Long would be a subclass of number. Basically, this is inheritance, right? You are inheriting integer, float, long, double, and everything from number class. So number is a superclass and all this integer, float, and everything is a subclass of number. So when it comes to protected, it says that it is visible to the package and all the subclasses. So just to keep in mind, as of now, you can think of access modifier as visibility of a particular component, or could be visibility of a class or visibility of a method or an instance variable as well. This is what drives the encapsulation factor of object-oriented paradigm. So basically, we control the access for all these components, or we control the access of class, variables, methods, and everything, which makes it encapsulated. Cannot be breached, sort of. As we could see, this is like I could make this one as default as well. All right, so this is default scope. It would still run because it's within the class. Right now, suppose I make this one as private, right? Just to show you what this encapsulation is all about or what this access modifier is all about. Suppose I make this one private, right? Still this one runs because it's within the class. You are trying to access it within the class. Now I create a new class. Say for example, we say access modifier test. So I create a main class here again, main method. Now suppose if I try to run this, right? So basically I create the same stuff here. Say I create a hello world object. Okay. Now this one is private, right? Now if I try to access it from here, what I was trying to say is if I, so as you could see here, it says that non-static test has a private access to hello world. So you cannot use it from outside. That's what I was trying to say. So basically, since it has got a private scope, you cannot access it from other class. And if I remove this private now, which gives it default scope, and as we said, default is nothing but it has got access within package. You could see this error going off here. Now it is accessible, right? So that's what it is all about. When you have a private scope, it's within a class, whereas default is within a package. Public is accessible anywhere and protected is visible to the package and just the subclasses. So let's talk about non-access modifiers. This is not controlling that method or variable. When it's static, you need not create object of a class. So basically for static test, you could see that we didn't create object of a class. We didn't call static test on a particular object of a class. It could be called directly. That's what static is all about. The static modifier for calling methods and variables without an object to which it belongs. As we saw, we didn't create object of hello world. We directly call the static method. Final is nothing but you can't change it. Final, as the name suggests, you can't change it once it is created. So finalizing the implementations of classes, methods, and so this is nothing but instance variable, which we would be talking about the slides to come. Just to tell you, this is an instance variable which we have assigned the value 10. Now suppose within this particular method, I try to change the value to 11. You would get an error saying that cannot assign a value to a final variable. So final is like it's final, can't change it. Once you have created it, you can't change it. But if I remove this final, you could see this error would go off. You don't see this error anymore. Whereas by putting final, you would see this error. So that's what final is all about. So basically, this is good enough for constants, right? So if you have constants within your class, you would make it final so that no one can change it. Abstract is nothing but you could mention it as abstract when it doesn't have implementation of all the methods. So what I'm trying to say is abstract modifier is again a non-access modifier, and what it tries to say is, say for example, you have a shape class. Shape class is an abstract class because shape doesn't say you want to calculate area of shapes. So basically shape class by itself wouldn't know what the area of the shape would be. Shape is a class wherein it's a generic class. It doesn't know what the implementation of area would be. For square, it would be side square. For rectangle, it's length into breadth. Or circle, it's pi r square. So basically shape